For many, the Green Revolution is seen as one of the most important movements in modern society. Wind turbines, solar panels, electric vehicles, the technologies that promise a cleaner future are being rolled out at an unprecedented scale. But what most people don't realise is that these systems are not just built with innovation, they are built with an extraordinary amount of raw materials. You cannot have large-scale green infrastructure without large-scale mining. That isn't an opinion, it's a physical reality. Every wind turbine, every solar panel, every electric vehicle begins the same way. Not in a factory, but in the ground. Before anything becomes clean energy, it exists as ore. Rock that has to be found, drilled, blasted, crushed, processed and refined. The Green Revolution doesn't remove this step, it depends on it entirely. Take copper for example. It's the backbone of electrification. It runs through transmission lines, substations, electric motors, charging networks, and renewable infrastructure. Without copper, electricity cannot be efficiently moved from where it is generated to where it is used. A single electric vehicle uses far more copper than a conventional car. A single wind turbine contains tons of it. Expand that across entire nations transitioning to electric transport and renewable grids, and the scale of demand becomes immense, far beyond what most people ever imagine. Then there's lithium. It has become the symbol of modern batteries, but lithium is only one piece of a much larger puzzle. Nickel is used to increase energy density, allowing batteries to store more power in less space. Cobalt stabilizes battery chemistry, preventing overheating and extending lifespan. Manganese is often added to improve performance and durability, and graphite, rarely mentioned, makes up a substantial portion of the battery itself. Without graphite, lithium-ion batteries simply do not function. And beyond batteries, there are rare earth elements. Neodymium and praseodymium are essential for the powerful permanent magnets used in wind turbines and electric motors. These magnets allow turbines to generate electricity efficiently, and motors to operate with high performance. But extracting and processing rare earths is complex, often involving challenging chemistry and significant environmental considerations. Solar panels rely on high-purity silicon, refined from quartz through energy-intensive processes. Silver is used in small but critical amounts to conduct electricity within photovoltaic cells. Aluminium frames hold panels together, and steel structures support entire solar arrays across vast areas of land. These are not niche materials used in small quantities, they are required at industrial scale. To build a single large wind turbine can require hundreds of tons of steel, substantial amounts of copper, and specialized materials for magnets and electronics. Multiply that by the number of turbines required to supply meaningful energy to entire regions, and the numbers quickly become staggering. Electric vehicles follow the same pattern. Each one contains a battery weighing hundreds of kilograms, built from minerals that must be mined, transported, and refined. Replacing even a fraction of the global vehicle fleet with electric alternatives means extracting and processing vast quantities of these materials. And unlike fuel, which is consumed gradually, these materials must be sourced up front, before the system can even begin operating. This is where the narrative begins to fracture, because while these technologies are often presented as clean, sustainable, and environmentally friendly, the process required to build them is anything but invisible. Mining is one of the most intensive industries on Earth. It reshapes landscapes, generates enormous volumes of waste rock, consumes significant energy, and requires infrastructure on a massive scale. There is no version of this transition that avoids those realities. And yet, at the same time, there is a growing movement that pushes for rapid expansion of renewable technologies while opposing mining activity. Mines are protested. Projects are delayed or cancelled. Resource extraction is framed as something inherently destructive that should be reduced or eliminated wherever possible. This is where the contradiction becomes impossible to ignore, because the systems being advocated for cannot exist without the very industry being opposed. The Green Revolution is not a move away from extraction. It is just a transformation of extraction. For over a century, industrial society has been built on fossil fuels, coal, oil, and gas. These resources are extracted, transported, burned, and consumed continuously. Every unit of energy requires more material to be taken from the ground and used once. Renewable systems change that model. Instead of continuous fuel consumption, they rely on large upfront material inputs. You build the infrastructure, the turbine, the panel, the battery, and then it generates energy over time. But that upfront input is not small, it is massive. Global demand for critical minerals is already rising, and projections suggest it will increase dramatically in the coming decades. Copper demand is expected to surge as electrical systems expand and electrification accelerates. Lithium demand is increasing rapidly as battery production scales. Nickel, cobalt, and rare earth elements are becoming strategically critical resources. This isn't a minor adjustment to existing industries, it is one of the largest shifts in resource demand in modern history. New mines will need to be developed, existing operations will need to expand, exploration will intensify in regions that were previously overlooked. Countries with significant mineral wealth will become increasingly important in global supply chains. From a geological perspective, this is a fundamental reorganisation of how society sources the materials it depends on. And yet, much of the public conversation still treats renewable energy as if it exists independent of this reality. It doesn't. Every piece of green technology is, at its core, a product of geology. It is refined earth material, engineered into a functional system. The clean energy future is built from rock, transformed through industrial processes into metals, components, and infrastructure. That doesn't mean a transition has no value. It doesn't mean renewable technologies don't reduce certain impacts, particularly emissions during operation. But it does mean that the idea of clean energy is often misunderstood, because clean at the point of use does not mean clean at the point of origin. The environmental cost has not been eliminated, it has been relocated, from the atmosphere to the ground. And that shift comes with its own set of challenges. Mining operations can disturb ecosystems, alter landscapes, and generate large volumes of waste material that must be carefully managed. Processing ores often requires chemicals and significant energy input. Supply chains can extend across multiple countries, sometimes involving regions with weaker environmental protections or labour standards. These are real issues. They are part of the true cost of the materials being used. Ignoring them doesn't make them disappear. If anything, ignoring them makes the transition less sustainable, not more. Because a system that depends on materials must also take responsibility for how those materials are sourced, processed, and ultimately recycled or disposed of. This is where the conversation needs to become more grounded, not in slogans and not in simplified narratives, but in physical reality. If society wants large-scale renewable energy, then it also must accept large-scale mining. The focus should not be on pretending that one can exist without the other, but on ensuring that mining is done as responsibly and efficiently as possible. That means improving environmental standards and rehabilitation practices. It means investing in technologies that reduce waste and energy use during processing. It means developing recycling systems that can recover valuable materials from batteries, electronics, and infrastructure at the end of their life. It also means acknowledging that some level of environmental impact is unavoidable, because without mining, there are no materials, and without materials, there are no systems. There are no wind turbines without steel towers and copper wiring, no solar panels without silicon and silver, no electric vehicles without lithium, nickel, cobalt, and graphite, no modern electrical grid without vast quantities of conductive metals. These are not optional components, they are fundamental. The Green Revolution is not powered by ideas alone, it is powered by materials, and those materials come from the earth. The sooner that reality is acknowledged, the more honest the conversation can become. Because only then can meaningful decisions be made about how to balance environmental goals with the resource demands required to achieve them. Understanding that behind every clean-looking technology is a chain of extraction, processing, and manufacturing that begins far from where the final product is used. Understanding that reducing one type of impact often introduces another. Understanding that sustainability is not about eliminating impact entirely, but about managing it responsibly. Because the future being built is not one without cost. It is one where the costs are different, less visible, and often misunderstood. And if those costs are ignored, the entire system risks being built on assumptions rather than reality. The ground beneath our feet still matters. It always has. Every advancement in human history, from the Bronze Age to the Industrial Revolution, has been defined by the materials we extract and how we use them. The Green Revolution is no different. It is simply the next chapter in that story. A chapter that depends, just as much as any before it, on what lies beneath the surface. And whether we acknowledge it or not, every step toward a greener future still begins with the decision to dig. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.